Hello everyone, myself Vinay Kumaram. I am pursuing PhD in physics. So in this particular YouTube channel, I will be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So in my previous videos, I was actually explaining the first chapter of 9th standard mathematics, that was on number system. So till now I have completed most of the examples and exercise 1.3. So from this particular video, we'll focus on the next topics which are there in this particular chapter. So the next topic which is there in this particular chapter is operations on real numbers. In my previous videos, I have explained you what do you mean by real numbers. So real numbers have rational numbers, you have integers, you have natural numbers, you have whole numbers. Along with this, you will also have irrational numbers. So all these numbers will be there in real numbers. So that means all these numbers are clubbed together to be known as real numbers. And in this real number system, how operations work out, that is plus, minus, multiplication and division, how these operations work with respect to real numbers. So in this particular concept, we'll just look out for some fun using this particular number. So if you refer my 8th standard videos, there I have explained about rational numbers. In rational numbers, I have also explained how rational numbers obey commutative law, distributive law and associative law. Along with that, how rational numbers are closed under multiplication, addition, division and subtraction. So if you want more details about that, you can refer my 8th standard mathematics videos. So in this particular video, we'll try to understand how operations on real numbers work. So basically, we will concentrate more on irrational numbers, because in this particular chapter, the new number system which you are coming across is irrational numbers. So that's why we will focus on irrational numbers. Now, in irrational numbers, whenever you take addition, subtraction, multiplication or division of two irrational numbers, then what will be the result? So for example, root 2 and root 2. So now root 2 is also an irrational number and root 2 is also an irrational number. When I multiply these two irrational numbers, what I will get is root 2 into root 2 is equal to root 2 whole square. So root 2 whole square is 2. So 2 means we are getting a rational number. So this is a rational number. So that means you are multiplying two irrational numbers to get a rational number. Similarly, this is not always true, because sometimes if I take pi and if I take root 2 and if I multiply pi with root 2, then here the value for pi is 3.142. It goes on like this, and value for root 2 is 1.414 and it goes on like this. So now if I do multiplication of pi and root 2, that is if I do multiplication of two irrational numbers, then there is a possibility to get another irrational number. So that means whenever you multiply two irrational numbers, either you can get a rational number or you can get an irrational number. So now if I consider the division, if I consider root 2 by root 2, then this gives you 1. That means division of two irrational numbers. So that means if you are dividing an irrational number with another irrational number, then you might get a rational number. Or if I am dividing pi with root 2 or root 2 by pi, so if I am doing this, then I will get irrational number only. So that means whenever you divide a particular irrational number with another irrational number, then you might get a rational number or irrational number. Similarly, if you add two irrational numbers, so for example, if I consider root 2 and if I consider minus root 2, and if you are adding these two irrational numbers, then this will give you root 2 minus root 2, which is 0, and 0 is a rational number. But in another case, if I give you root 2 plus root 2 without giving this minus, then the answer for this will be an irrational number. So that means here addition of two irrational numbers can give you rational number or irrational number. Similarly, if I take subtraction, that is if I take subtraction between root 2 and root 2, that is if I put minus, then I get rational number. Similarly, if I do subtraction between root 2 and root 3, I get irrational number only. I don't get rational number. So that means subtraction of two irrational numbers sometimes can give rational number, sometimes it can give irrational number. So that means if I generalize this, irrational number multiplied with an irrational number can give you either rational number or irrational number. RAT means rational number, IRR means irrational number. Just I am giving some idea about this. So similarly, if you do irrational number divided by irrational number, then also you can either get rational number or irrational number. Similarly, if you do irrational number minus irrational number, and if you do irrational number plus irrational number, means if you are doing the operations between two irrational numbers, that is plus, minus, into and divided by, between two irrational numbers, then either you will get a rational number or irrational number. Here also you will get rational number or irrational number. So now, what if I do addition or subtraction between rational number and irrational number? So for example, if I consider 2, which is a rational number, and if I consider root 2, that is an irrational number, 2 plus root 2 will give you 2 plus 1.414, and it goes on like this. So 2 plus 1.414 is nothing but 3.414 and goes on like this. So that means here also you are getting irrational number. So always remember, whenever you are adding a rational number and an irrational number, always you will get irrational number. Similarly, if you are subtracting rational number and irrational number, that is if you are doing 2 minus root 2, then you will get 2 minus 1.414 and it goes on like this. So here also when you do this, again you will get an irrational number only. So that means whenever you are doing sum or difference, so that is whenever you are adding rational number and irrational number, or if you are taking difference between rational number and irrational number, then you will get only irrational numbers. So whenever you do rational numbers and irrational number addition or subtraction, that is if you take one rational number and one irrational number, and if you take sum or difference of that rational number and irrational number, you will always get a irrational number only. If you are doing product or division using rational number and irrational number, then you will always get irrational number only. So here also, if you are taking rational number and multiplying with irrational number, then you will get irrational number only. So all these things you should remember, and you can try various examples to cross verify these particular statements what I am telling here. So again, if you take rational number divided by irrational number, or irrational number divided by rational number, you will get irrational number only. So you can consider multiple examples and cross verify this. See, now if I take 2 into root 2, again when you take 2 into root 2, it is 2 into 1.414 and it goes on like this. Since there is an irrational number multiplied with rational number, always the answer will be in irrational number only. So the answer for this will be 2.828 and it goes on like this. So that means product of a rational number and irrational number is always an irrational number. Similarly, if you do division of a rational number and irrational number, in between rational number and irrational number, then also you will only get irrational number. So that means here you did rational number plus irrational number, rational number minus irrational number, you only got irrational number. Similarly, when you multiply rational number with irrational number, or whenever you do division between rational number and irrational number, always you will get irrational number only. See, in the previous case, when I discussed about the difference between two irrational numbers or sum between two irrational numbers, that is when you take difference between two irrational numbers, sum between two irrational numbers, division or multiplication between two irrational numbers, result might be either rational number or irrational number in all these cases. But whenever you are doing sum, difference, product and division between a rational number and irrational number, then you will always get irrational number only. So after understanding this, now we will try to solve example 11. So in example 11, they have given certain numbers. So you have to tell whether they are irrational numbers or not. So here the first question is 7 root 5. So here we have first question as 7 root 5. So here clearly you can see there is a rational number and clearly you can see there is an irrational number. So that means this is a rational number multiplied with irrational number. So always when you multiply rational number with irrational number, you will get irrational number only. Just now I have explained that. So now if you take the value of this 7 root 5, that is 7 into 2.236 and it goes on like this. So this root 5 is an irrational number. So now if you multiply 7 with this particular irrational number, so there are so many non-ending numbers after decimal point. That means there is non-terminating decimal expansion. So that means when you multiply a rational number with that non-ending or non-terminating decimal expansion, then again you will get a non-ending or non-terminating decimal expansion. So that's why whenever you multiply rational number with an irrational number, you will get irrational number only. So 7 root 5 is an irrational number. Now coming to the second question in the same example 11, here they have asked, so here 7 is a rational number and root 5 is irrational number. So that means here rational number divided by irrational number will give you irrational number only. So now there is one more question, that is root 2 plus 21. Here also you can see rational number plus irrational number is there. So sum of a rational number and irrational number will give you irrational number. Now we have one more example, that is pi minus 2. Here also 2 is rational number, pi is irrational number. So difference between a rational number and irrational number will always give you irrational number. So all the numbers which are given in this example 11 are irrational numbers. So now let us look on to example 12. Here they have given two numbers. One is 2 root 2 plus 5 root 3 and they have given one more, that is root 2 minus 3 root 3. So these two you have to add together. So let us try to add 2 root 2 plus 5 root 3 plus, so always remember you should put bracket before removing the bracket. So plus root 2 minus 3 root 3. So now you can remove the brackets. So 2 root 2 plus 5 root 3. Here plus is there inside for this root 2. So plus into plus is plus. So plus root 2. Here plus into minus is minus. So minus 3 root 3. So now you can see here in this particular term and this particular term, root 2 is common. So here just root 2 is there. Just root 2 is there means it is 1 into root 2. So now you can take root 2 common and 2 plus 1 you can do. Plus here also root 3 and root 3 are common. So root 3 you can take outside. 5 minus 3 will be there inside bracket. So 5 minus 3 is 2. 2 plus 1 is 3. So that means 3 root 2 plus 2 root 3. So this is the simplified form of this particular addition. So coming to example 13, here you have to multiply 6 root 5 with 2 root 5. So here directly you can go on multiplying. Here you have 6 into root 5 into 2 into root 5. So that is nothing but 6 into 2 into root 5 into root 5. So 6 into 2 is 12, root 5 into root 5 is root 5 square. So that is equal to 12 into root 5 or 12 into root 5 square. So root 5 square is 5. So 12 into 5 will be there. So 12 5 is 60. So here you can see 6 root 5 is the irrational number and 2 root 5 is also an irrational number. When you are multiplying irrational numbers, you are getting a rational number. So that means whenever you do multiplication, division, addition, subtraction of two irrational numbers, you might either get rational number or irrational number. But whenever you do multiplication, addition, subtraction, division between a rational number and an irrational number, then you will always get irrational number. So to make understand about this particular concepts what I have told, these examples are given in the textbook. So looking at these examples, you can cross verify those statements which I told earlier. So like this, you can go on exploring multiple examples to understand how two irrational numbers, operation between two irrational numbers and operation between one rational number and one irrational number, how it works, what might be the result. So that you can cross verify using multiple examples. So in my previous video, I have explained how root 2 and root 3 can be located on number line. So on how root 4, root 5, root 6 so can be located on number line also you can calculate. So in my previous video, I have explained how we locate root 2 and root 3 on number line. So you can refer those videos. So in this particular video, we'll try to understand how to locate root 3.5 on a particular number line. So in order to locate root 3.5 on a number line, first you can draw a particular line which has unit equal to 3.5. So let's say there is a particular line which has naming A and B, and the length of this A and B, let it be 3.5 units. Now from B to C, so let's draw a small line here to identify B. So now you have A and B, and let us draw extension of this particular B. Let us draw an extension of this line from B till 1 unit. So that means let us stop over here where we'll call this point as C, and the length between B and C is 1 unit. So now the length between A and B is 3.5 units and length between B and C is 1 unit. Now you can consider the exact center point of this particular line. So let's say the exact center point of this line somewhere here it might be there. So let us call this center point as O. So this 3.5 is from A to B, and we have O here as the center of this particular line. So now you can take a compass. By keeping one end of compass here and by keeping another end of the compass on A, you can draw a beautiful semicircle like this which connects A and C. So now you have a semicircle with O as the center, and radius of this particular A to O can be considered as 3.5 plus 1 divided by 2, because here you have 3.5 from A to B and from B to C you have 1. So that means whenever you add 3.5 and 1, you will get the total length AC, and the total length AC is passing through the center O. So that means AC is the diameter. So now if you want to get the radius of this semicircle, that is AO, so that means this is the radius of this particular semicircle, that is A to O. So this is the radius of semicircle. So if you want to get this radius of semicircle, that is AO, then you have to consider that AC and you have to divide AC with 2. So when you do AC by 2, that is 3.5 plus 1 divided by 2. So that means here AO we are getting as 3.5 plus 1 divided by 2. So this is the radius of the circle. So now you have this particular semicircle. So I'll draw the semicircle once again. So you can draw a beautiful semicircle using compass. So here we have B and here we have C. So this is B and this is C. This is C. Here A is there, and at the center of this line you have O. Now you can draw a perpendicular line for this particular AC at B. So this perpendicular line should intersect this particular semicircle like this. So I have just drawn a perpendicular line to AC where this is intersecting this particular semicircle's circumference. So now this point you can call as D. Now try to connect D and O like this. So now you can just connect D and O like this. So always remember, this is radius AO and this is OB and this is BC. Now we will try to calculate what is AO, OB and BC. So anyway, BC is 1. So radius is 3.5 plus 1 divided by 2. So the total length from A to B is 3.5. So then what will be the OB value? So here in this particular figure, OB is equal to AB minus AO. Because you can see here, if you want this particular OB value, so if you want this particular OB value, so then you have to subtract this particular AO with this particular AB value. So that means to get OB, you have to subtract AO with AB. So that is AB minus AO. So when you do AB minus AO, you will get this OB. Because I want this particular OB in order to calculate the length of this particular BD. So here we have OB and OD and DB. DBO. I am just writing that right angle triangle separately. So that is OBD. Now we want to calculate what is the value of this particular DB. So we have to calculate this value of DB. So in order to calculate that, we want this OB. So that OB we are getting by subtracting AO with AB. So that is OB is equal to AB minus AO. So what is AB? AB is 3.5 minus, here AO is 3.5 plus 1 divided by 2. Now we got the OB value. So here in this particular right angle triangle, I'll write this in a new slide. So in this particular right angle triangle, you have B, you have D and you have O. So the value of OB is 3.5 minus 3.5 plus 1 divided by 2, and this 3.5 plus 1 divided by 2 will be there in bracket. So this is the value of OB. So this is the value of OB. And what is the hypotenuse? So here in the image you can see the hypotenuse is nothing but the radius of the semicircle. I am connecting O and D. So that means I am connecting from the center of the semicircle to the circumference of this particular semicircle. So that means radius of this semicircle is OD. And the radius of this semicircle is 3.5 plus 1 divided by 2. So that means the value for OD is 3.5 plus 1 divided by 2, that is OD, because OD is radius of this particular semicircle. So now you have OB value, now you have OD value. So now you can calculate this DB value. So according to Pythagoras theorem, OD square is equal to BD square plus OB square. Now we want to calculate the value for BD. So that's why we have to bring this OB square to LHS, so that will become minus OB square. So that is OD square minus OB square is equal to BD square or DB square, which is equal to OD square minus OB square. So what is OD square? So OD square is anyway radius. So here we have taken OD as 3.5 plus 1. So here you can see OD we have taken as 3.5 plus 1 divided by 2. So here in the place of OD square, you can substitute 3.5 plus 1 divided by 2 whole square minus OB square is there. So OB square is nothing but this particular value, that is 3.5 minus 3.5 plus 1 by 2. So that means here 3.5 plus 1 divided by 2, this will be in the bracket. So whole square will be there. So now we have this particular DB value. So now if you try to expand this, dB square is equal to 3.5 plus 1 by 2 whole square minus, inside big bracket you can take 3.5 whole square plus 3.5 plus 1 divided by square minus 2ab is there. So 2ab means 2 into 3.5 into 3.5 plus 1 divided by 2. So this entire thing will be there in the bigger bracket. So now dB square is equal to, now you can bring all these values outside bracket. So that will be 3.5 plus 1 by 2 whole square minus 3.5 whole square minus 3.5 plus 1 divided by 2 whole square. Here you can see minus 2 into 3.5 into 3.5 plus 1 by 2 is there. So outside also minus is there. So minus into minus will give you plus. So that's why plus 2 into 3.5 into 3.5 plus 1 divided by 2. So here you can clearly see 3.5 plus 1 by 2 whole square is there. 3.5 plus 1 divided by 2 whole square is there. So same value is there. But here minus is there. Here plus is there. So that means these two values can get cancelled with each other. So that means here we are getting dB square is equal to minus 3.5 whole square plus 2 into 3.5 into 3.5 plus 1 divided by 2. So now you can solve this. So here you can clearly see in this particular value, in the numerator 2 is there, in the denominator 2 is there. So this 2 and this 2 gets cancelled with each other. You can't cancel with this particular value because here plus is there. Since here multiplication is there inside this, so in this particular value only I am cancelling this particular 2 and 2 which is there in the numerator and denominator. So now the thing that which is remaining is minus 3.5 square will be there plus, so in this bracket you have 3.5 into 3.5 plus 1. So that is 3.5 into 3.5 plus 1 is there. So minus 3.5 square plus, here 3.5 into 3.5 is 3.5 square. 3.5 into 1 is 3.5. So now we can bring this outside bracket. So that is minus 3.5 square plus 3.5 square plus 3.5. So here this 3.5 square minus 3.5 square can get cancelled with each other because here also 3.5 square is there, here also 3.5 square is there, here minus is there, here plus is there, so you can cancel this each other. So the only remaining answer is plus 3.5. So here dB square is equal to plus 3.5. So that means dB value is square root of 3.5. Now coming back to the semicircle, here in the semicircle we had this particular position as B and this particular position as C and this particular position as A, and there is a semicircle like this, and we have drawn a perpendicular line from B to the semicircle intersecting the semicircle circumference. So here we got the center of this particular line, that is O, and here we have named this particular point as D. So this value we have considered as root 3.5. So that means here I have got the value for dB. So that means the value of this particular dB is root 3.5. Now you can place this particular semicircle on number line in such a way that you place this B on 0 and this particular C on 1 because the difference between B and C is 1 unit. So we have considered the length between B and C is 1 unit. So keep B on 0 and keep C on 1 on the number line, and in such a way you can place the this particular semicircle on number line. So if you do that, if you have a number line like this, that is starting from 0, 1, 2, 3, and on the left hand side of number line you have minus 1, minus 2, minus 3, minus 4. So here from this particular position, that is minus 3.5, we can consider as A because distance between A and B is 3.5. This particular 0th position I'll consider as B, and this particular 1 I'll consider as the position for C. So here you'll have a semicircle like this, and from this B we have drawn a perpendicular line like this. So this is D. So that means here this particular BD value is root 3.5. Now making this OD as the radius, you can keep a compass one end on this particular B position. So this is not O, this is 0, because O comes somewhere here. So O comes somewhere here. So here this particular value is 0, on which I have kept this particular B. So taking this B and BD as the radius of a new circle, you can place one end of compass on this B and another end of compass on this D, and you can draw a semicircle like this. So somewhere at this particular position, your circumference of this circle will be meeting. So you are considering BD as the radius and you are drawing another circle. So in order to bring that BD onto the number line, so that means this particular position on number line is root 3.5. So that means here the simplified way to locate any these kind of decimals on the number line, you can just consider the length of that particular decimal. So now we can generalize this by taking 3.5 as x. So whenever you want to calculate a root x, so in this case it is root 3.5, because we are considering 3.5 as x, we can take root x. So simply you can consider A and B, where the length between A and B is x and the length between B and C is 1 unit. And you can draw a semicircle between A and C, and you can draw a perpendicular line from B onto AC to intersect this particular semicircle at D. Now you can consider the center of this particular line as O, and you can connect this OD, radius of this semicircle, that is AO. So radius of the semicircle will be x plus 1 divided by 2, because the total length of this AC is x plus 1. So x plus 1 divided by 2 will be the radius of this circle. So x plus 1 divided by 2. So I'm just generalizing whatever I have done till now. So similarly, using this particular method, you can calculate root 7.5, you can calculate root 8.5 on the number line. So you can locate root 7.5, root 8.5 on the number line using this particular procedure. So this is all there in this particular video. So the next exercise 1.4 is there. So that particular exercise 1.4 I'll be solving in my next video. So until then, if you want to learn more physics, chemistry and mathematics starting from 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.